Hi, everybody. Welcome to the self-check 3.3 exercises. So let's go ahead and look at number three. The demand for an electric fan is related to its selling price P in dollars by the equation N equals 2,880 minus 90P, where N is the number of fans that can be sold per month at price P. Find the selling price that will maximize the revenue received. So just remember that we need to find the revenue function. So here, revenue will equal the price times the number of fans sold. Okay, so that means the revenue function will equal price P, right? Times N, just the number of fans sold. We don't really know the price yet of the fans we're setting it at, but what we do know is the number of fans that can be sold with this equation here. So what we can do is plug in this guy here, that N equation there, our number of fans sold, into this equation here. Okay, so that is our revenue function. Let's go ahead and distribute in that P just to clean up this function. So I'll have 2,880P minus 90P squared. And that is my revenue function. Okay. But what is the question asking? It's asking us to find the selling price that will maximize the revenue received. So what I need to do here is find the maximum selling price. So when you hear the words maximum, maximum or minimum, right? That means the derivative. So what I have to do now is find the derivative of this revenue function. So the derivative of this revenue function is going to be P is our variable, right? Maybe I should change this a bit, have it as P. One second, pardon me. Function of P, right? Let me change this one too. I need to find the derivative of this as a function of P, our selling price, right? That's what we're trying to find. So that means if I take a derivative of this, the P just goes away, right? We just drop it. So it'd be 2,880 minus, this guy goes down, we subtract 1 from it, minus 180p. Okay, so we take the derivative, right? But how do we find the maximum? So what we need to do is actually set this equal to 0 and then solve for p. So take derivative, set equal to 0. Okay, so I'm going to set this equal to 0. And then just solve for p. So I'm going to add 180p to both sides. That cancels out. And so I'm going to move the work over here. But what I end up with is 180p equals 2880. Then I'm going to divide by 180 to both sides. And what I should end up with is 16. Okay, so that is my answer. So what does that mean in the context of this problem? That the selling price that will maximize revenue is $16. And that's my answer. Okay. Now let's go ahead and check out number 4. So number 4 says a homeowner wishes to insulate his 1,600 square foot house's attic. The total cost as a function C of R for inches of insulation, and the heating cost for that amount of insulation over the next 10 years is given by C of R equals 150 R plus 240 divided by R. So how many inches of insulation should be placed in the attic if the total cost is minimized? So same thing with the previous problem, right? We're trying to find how many inches of insulation should be placed to minimize the cost, right? We want to get the lowest cost possible. So once again, that's take derivative set equal to 0. Okay, so what I got to do is just take a derivative of this guy, set it equal to 0. So I'm just going to rewrite the function like C of R equals 150 plus 2,400 over R. Excuse me, forgot an R there. Let me rewrite this, sorry. 150 R plus 2,400 divided by R. Okay, so we know how to take a derivative of this. And this one, we're going to have to change a bit in order to take a derivative using that power rule. So to rewrite this, I will just write 150R. That stays the same. But what I'm going to do is bring this guy up and make it a negative exponent so I can take the derivative. So recall that it's R to the first power, so there's sort of that invisible 1 right there. So I could bring this up and make it R to the negative 1. So this would be 2,400 R to the negative 1. Okay, so now I'm set up to take a derivative using the power rule for both of these. So that means C prime of R equals 150. The R just drops, right? And then I'm going to bring that guy down and subtract 1 from it. So this would be, plus negative 2,400. Or you know what? I'll write out the steps. So this would be 2,400 times negative 1 R to the negative 2. Okay, so this becomes 150 plus, minus 2,400 R to the negative 2. Okay, so we have a negative exponent here. Let's go ahead and rewrite it as a positive exponent so that we can have regular algebra with it. So remember, to make it positive now, we can just bring it back down and make it a positive exponent. So what this would become is 150 minus 2,400 over R squared. And that is our derivative. Okay, so we took our derivative, right? Now we got to do is set it equal to 0 and find out how much insulation we need to minimize this cost. So let me go ahead and bring the work up here, but I'm going to set it equal to 0, right? So 0 equals 150 minus 2,400 over R squared. So I'm just going to add 2,400 over R squared to both sides. Okay, this guy cancels out. So what I'm left with is 2,400 over R squared equals 150. So I have this R squared on the bottom. I want to get it up to the top. So what I'm going to do is just multiply R squared to both sides. So these guys cancel out. What I'm left with is 2,400 equals 150 R squared. Okay, I still want to get R by itself. So I'm going to divide both sides by 150. That cancels out. And then 2,400 divided by 150 is going to be 16. Okay. And I still need r by itself. It's still r squared right now. So I'm going to take the square root of both sides. And what will we get? We will get r equals, what would we get plus or minus 4? But we're in the real world situation right now. You wouldn't have -4 inches of insulation. That wouldn't make sense. So r would equal 4. Okay. So what does this mean in context of the problem, right? That means to minimize costs, to minimize costs, 4 inches of insulation should be placed in the attic. Okay, so that is the answer. And that does it for this video for 3.3 self-check. I'll see you next time. Thank you. Bye.